Assalamu alaikum. In this video, we are going to solve question 6 from May-June 2024 paper 1 variant 1, which covers rational functions. Let's read the question. The curve C has equation y equal to x square plus ax plus 1 and in denominator x plus 2 where a is greater than 5 upon 2. In first part it is saying find the equations of the asymptotes of C. Okay, so what are asymptotes? There are two types of asymptotes, not two. Like when the question, let me explain my statement. When the question says equations of asymptotes, when the question says equations of asymptotes, so we will have two ways, not two types of asymptotes. We will have two ways. There will be one vertical asymptote and the second one is horizontal asymptote or vertical asymptote, or oblique asymptote. Only one of them, there will be horizontal asymptote, so there will not be oblique asymptote. If there will be oblique asymptote, so there will not be horizontal asymptote. Are you getting my point? When horizontal asymptote occurs, when the degree of numerator is less than degree of denominator. Let me tell you, if there is x and this, then here will be horizontal asymptote. If it is x square plus 4x in numerator and denominator it is x cube plus 3, there will be horizontal asymptote. If the numerator, if the degree of numerator is greater than degree of denominator, there will be oblique asymptote. Let me give you example. If there is x cube upon x, if there is x square plus x divided by 5x, so here the x cube is in numerator while there is only power is 1 on the denominator of x. So let's move ahead. So wait, there is one thing remaining. How we will find out vertical asymptote? To find out vertical asymptote, we will set denominator equal to 0. Okay, if there is x plus 2 upon x plus 3, so vertical asymptote will be x plus 3 equal to 0 and this will be x equal to minus 3. Okay, so let's now come back to the question. Okay, so find the equations of asymptotes. So first we will go for vertical asymptote. What we had discussed, to find vertical asymptote, we set the denominator equal to 0. So what is denominator? Denominator is x plus 2. So we will do x plus 2 equal to 0. So there will be x is equal to negative 2 as a vertical asymptote. And when there will be x is equal to negative 2, how we will sketch it? It will be like this. It will move upward. It will go downward. Which means that y tends to plus minus infinity. Okay. Then we will first determine there will be oblique asymptote or horizontal asymptote. If we look at the equation, we notice that the x square, there is the highest power of degree of polynomial while there is x power 1. So we can say that degree of numerator is greater than degree of denominator. So there will be oblique asymptote. Okay. Now there will be oblique asymptote. Now the discussion is this: how can we find out oblique asymptote? As I have told you, the vertical asymptote can be find out by equating the denominator with 0. How we will find out the oblique asymptote? To find out oblique asymptote, we will perform long division. We will perform long division. How we will perform long division? Let me show you. We will write denominator here x plus 2 and numerator here x square plus ax plus 1. Okay, so now we have to form x square, and what we will multiply with this to make the x square? We will multiply x to make x square. If we multiply x with x, it become x square, and then we will multiply 2 with x, it become 2x. Now we will flip signs here. When we flip the sign, it got cancelled here. And now we will go down. And here I have ax minus 2x. Or if I write it as a minus 2x plus 1. Now what I will multiply with this to get a minus 2 in the bracket multiplied with x? Obviously we will multiply a minus 2 here. If we multiply a minus 2 with x, it becomes ax minus 2x, which will obviously can be written as a minus 2x. And then you multiply a minus 2 with 2, so it becomes plus 2a and minus 4. Again, now we will flip signs. It got negative, it got negative, it got positive. Now we can cancel these two brackets, and here we will get 5 minus 2 as a remainder. Okay, so we got oblique asymptote. Now the question is, if this is oblique asymptote, if this is oblique asymptote, if this is oblique asymptote, or if this is oblique asymptote. This is a question of a student. Now let me tell you, where is the oblique asymptote? The oblique asymptote is, this is the oblique asymptote. So now I can write y is equal to x plus a minus 2. This is the oblique asymptote. There were 3 marks. How the examiner will reward us 3 marks? The 1 mark will be awarded for this. 1 mark will be awarded for this long division, and the last mark will be awarded for this. Okay, to get 3 marks, you have to show these 3 things, and then you will get complete 3 marks. Now we are moving ahead to find out to go for the part B. Okay, in the part B, the question is saying show that C has no stationary point. C has no stationary point. Okay, wait for a bit. C has no stationary point. We have to show this. We will just simply try to find out stationary point, and in the end we will not get stationary point. It means there are not stationary points. I have a question. How can we find out stationary points? The answer will be, we can find out stationary point by 2 methods. One is differentiation and the second one is discriminant. both can be used, but through the practice we can get it where which method we have to apply. As in this condition we had already did long division, so we can get our equation, our main equation of curve y is equal to x plus a minus 2, and then remainder plus remainder is 5 minus 2a, and then denominator was x plus 2. Now the student asked what is the logic behind this to write like this. Okay, you asked what is the logic. Let me give you the logic. If we divide 21 by 4, so how we will divide it? We will say here will be 20, and if we multiply 4 by 5 it will be 20, then we will subtract it and we will get 1. Then we can write it as 21 upon 4 as 1, sorry, not 1, 5 1 upon 4, like a mixed fraction. But in reality there is nothing like a mixed fraction in the mathematics. The reality is this: we will write it as 5 plus 1 upon 4. If we multiply, let me show, is 5 plus 1 upon 4 is equal to 21 upon 4 is not, or not. 4 by 5 becomes 20, 20 plus 1 upon 4. Let's prove it is a 21 upon 4. Okay, so what do we get? That we will write this thing here, okay, plus remainder divide by denominator. Okay, similarly we copied this here, then we write remainder and upon denominator. I hope you get this idea. Now the student asks why we write in this form. We can differentiate it directly. Yes, you can differentiate it directly, but instead of using product and quotient rule, I prefer you to go like this, because there will be no rule to apply. There will be just simple differentiation. Let me show you how. Dy over dx equal to, if we differentiate x it become 1. Differentiation of a is 0. Differentiation of negative 2 is 0. We have to differentiate this box. Okay, let me show you its differentiation. It is 5 minus 2a upon x plus 2. Okay, we can write it as 5 minus 2a multiplied by x plus 2 power minus 1. Wait for a bit, let me write here bracket also. Yeah, okay. What we will do, this negative sign will go down here, so we can write minus 5 minus 2a x plus 2, and in its power it will be minus 1 becomes minus 2. So we can write it as minus 5 minus 2a upon x plus 2 whole square. So this is the differentiation. So I can write here 5 minus 2a upon x plus 2 whole square. I hope you get the differentiation. Then when we have to find out stationary points, the dy over dx is equal to 0. Basic pure math of A levels. Here will be 0, and here will be 1 minus 5 minus 2a upon x plus 2 whole square. Okay, now what we have to do? Now I will write 5 minus 2a here, divide by x plus 2 whole square equal to 1. Now we will do 5 minus 2a equal to x plus 2 whole square. Now we will expand the bracket. We will expand the bracket as x square plus 4x plus 4. And now we will write it in general form. X square, wait for a bit. Okay, x square plus 4x plus 4. Then we will shift 5 minus 2a towards right. It becomes negative 5 plus 2a. So it will become x square plus 4x, and 4 minus 5 become minus 1 plus 2a equal to 0. Now I told you we will show there is no stationary points by using b square minus 4ac is less than 0. Okay, so b square minus 4ac, 4 square minus 4 1 minus 1 plus 2a. Simplify it, it becomes 16 minus 4 multiplied by minus 1 become plus 4, and then minus 4 by 2a become minus 8a. So it becomes 20 minus 8a. Okay, now let me tell you, as question says that a is greater than 5 upon 2, as a is greater than 5 upon 2, 20 minus 8a is less than 0. Now you can ask how do you know that it is less than 0? If we insert 20 minus 8, 5 upon 2, so it is 0. The point is a is not equal to, it is just greater than. So what is greater than 5 upon 2? 3 is greater than 5 upon 2. Now it will be 20 minus 24 becomes minus 4. Now if we write, as we go to the higher number than 5 upon 2, it will always be a negative number, which tells us that it will always be less than 0. So we got it that b square minus 4ac. So b square minus 4ac is less than 0. Thus no stationary point. Thus no stationary point. By the way, this thing is called proof by contradiction. The question is saying show that it has no stationary point, but first we started like it has a stationary point. When we do dy over dx equal to 0, when we say we have a stationary point, but the question was saying there is no stationary point, still we are doing dy over dx equal to 0, means we are doing proof by contradiction. We are going against the statement to prove that it is wrong. Okay, we try to do a stationary point. In the end we showed we are not getting a stationary point. I hope you get my point. Now we have to sketch. So first, what do we require to sketch? I am writing here to sketch we require vertical asymptote, we require oblique asymptote in this case, We require x-intercept. We require y-intercept. We require turning point. Okay. So, vertical asymptote. What is a vertical asymptote in this case? Vertical asymptote is x equal to -2. Okay. And oblique asymptote. Oblique asymptote is y equal to x plus a minus 2. And then x-intercept. Currently I am leaving this as, let me tell you how can you find out x-intercept. X-intercept, to find out x-intercept, we will equate this with 0. We will equate numerator with 0. Okay. To find out vertical asymptote, we did denominator equal to 0. To find out x-intercept, we do numerator equal to 0. And in the end, not in the end, it is asking for y-intercept. We can get y-intercept by this constant y 1 upon 2. Okay. If we have a fraction like this, x plus 5 upon 3, so here the y-intercept is 5 upon 3. If we have x square plus 10x plus 7x, there is y-intercept 0. Okay, as there is 0 upon 0, so there will be nothing y-intercept. Oh no, wait for a bit, there will be, I think, 0 y-intercept. Okay, we will look it in the case. Okay, so y-intercept will be 1 upon 2 here. And turning point, we proved that there is no stationary point, means there is no turning point. Okay, so one thing is remaining, x-intercept. Okay, and there is one more question which the students usually ask: how we will sketch oblique asymptote as we don't know a? Okay, that's a good question, I think, and I have a solution for this. Okay, as the question says a is greater than 5 upon 2, we can assume a equal to 3, a equal to 4, a equal to 5, any number. In this case, I am going to assume a equal to 3. Okay, so I am writing here a equal to 3. We are assuming, but we don't mention this in the sketch. Okay, don't mention this in the sketch. So now we can find out x-intercept. This is x square plus ax plus 1. X square plus ax plus 1 equal to 0. Okay, let's write 3 instead of a. Now use a quadratic formula, or you can use your calculator and find out what will be x. You will get the answer in third form. Instead of writing here in third form, you can write it in decimals, which will help you to sketch. I am getting -0.38 and -2.6. Okay, so -0.38 and -2.6. Okay, so now that we have gathered all our critical points, let's pull all together on this sketch. So first of all, let's draw our asymptotes as dashed lines. Remember, these acts as guidelines that the curve approaches but never touches. Okay, so first I will sketch our asymptotes. What is asymptote? First asymptote, vertical asymptote, is x equal to -2. What I said, that we will sketch dashed lines as these acts as guidelines that the curve never approaches, that the curve approaches but never touches. Okay, the curve will come towards it like this, but never touches it. It will go along with this. Okay, so this is x equal to -2. Then the second asymptote is x equal to a minus 2, y equal to x plus a minus 2, y equal to x plus a minus 2. And we had assumed that a equal to 3, so it becomes 3 minus 2 means y is equal to x plus 1. So y intercept is 1 here. We will not label it because in reality we don't know what is a, and the x intercept is -1. Now we can sketch a dashed line for oblique asymptote. This will not be straight, just I am giving you idea because I don't have any scale or any instrument here to draw on this page. Okay, wait, let me complete the question. The question asking for one more thing, stating the coordinates of point of intersection with y-axis. You can see it is not asking for x-axis, it is not asking for x-intercept, it is only asking for y-axis. We had find out that y-intercept is 1/2, so we will write 0, 1/2. 1 mark will be for this to writing here. Okay, so we are done with the oblique asymptote and vertical asymptote. Now we have to plot intercept points. Okay, plotting intercept points means our y-intercept is 1/2, so it can be here, and our assumed x-intercept is -0.38. As this is 1, this will be 0.5, so this can be okay, -0.38, and another one is -2.6, so it will be anywhere after the 2, so this. Okay, now we can sketch as everything is gathered here. So let's sketch it. Let me tell you, the curve will go along with this but never touches it. Okay, it will never do like this, it will never cross it, it will just go along with it. Now here we will be like this, sorry, the curve will be like this. Let me remove these points, as these points are not compulsory, or like it's a sketch, it's not a perfect plotting the graph. Okay, so these minor differences are acceptable. So here it will be like this. Okay, so this will be our sketch. There are no turning points. Okay, there are no turning points. Now we will move ahead, and in the next part it is asking for one more thing. I will prefer you to write origin here. In reality these axes are not drawn, I've drawn it by myself, so you have to also label y and x. These are compulsory, I think. Okay, the examiner can cut out marks, you don't need to give any chance to the examiner to cut your marks. Okay, now I will move ahead. In the next part it is saying sketch the curve with equation modulus x square plus ax plus 1 and x plus 2 is denominator. Okay, the same curve, we have to sketch the modulus of the same curve. Okay, can anyone notice why I didn't give a region below the x-axis? Can anyone guess? If you have guessed, so let me tell you that your guess is correct or not. The correct answer is, in the modulus, when the modulus will be applied, there will be no graph under the x-axis. The y will always positive. Okay, so let's sketch our graph. there is x equal to -2. This is x equal to -2, and then we have our second asymptote. We don't need a precise graph. This is the precise graph is not a requirement. Just you have to sketch, you have to show the asymptotes. Do you know the concept of asymptotes, that the graph will approach to it but never touches it? You have to show these things. Okay, and it will, this asymptote will move towards here. Wait, let me show you. Due to modulus, this asymptote will be here, but the mark scheme don't ask for this part of the asymptote, so I prefer you to rub it, and I will also rub it after the sketch. Okay, and what was the y-intercept? Y-intercept will be here, x-intercept will be here, and wait for a bit. Okay, that will be here. Now let's sketch. This was already in the previous curve. Now this region, which was this, it got reflected here. Okay, wait for a bit. Okay, let me rub this. Okay, so this will be how this will get reflected on the x-axis. Okay, now let's talk about this side. This side was like this in the previous part. You don't have to touch it to show your understanding about the asymptote. Wait, here it got touched it. Wait. OMG, okay, let you give me a bit time. I will do it in a second. No, the first attempt was really nice. Yeah, and now this will go here. This is basically a rough sketch, so you can make it better in the copy while I am doing in the mobile, so that's why it is not really good, but still it is not required precise sketch. Okay, just we have to show your understanding. Wait, let me tell you that also label this y equal to x plus a minus 2. Are you laughing on my x? Okay, so let me make it better. I hope this one is better. Okay, so let's move ahead. On your sketch in part 1, draw the line y equal to a. Okay, what was a? A is greater than 5/2. Okay, this is 1, this is 2, and this is 5/2. Okay, now we have to draw a line. Okay, this is our line y equal to a. This can be go ahead, this is not ended here, this can go ahead. Okay, so now we are done with these two parts. Now here is the last part of this question, and in this question it is asking for, it is given that modulus x square plus ax plus 1 divided by x plus 2 is less than a for negative and then this range is given. Okay, for x and this. Okay, find the value of a. We have to find out the value of a. Okay, to remove the modulus, what we have to do? When we remove the modulus, there is x square plus ax plus 1 upon, wait here, x plus 2. I am currently removing this sign and I am writing is equal to a. To remove modulus, we want 1a in plus and 1a in minus. So I will write here x square plus ax plus 1 upon x plus 2 is equal to minus a. Then we will further solve it, and when we solve it, it become x square plus ax plus 1 equal to ax plus 2a. And if we notice, this ax and this ax will get cancelled and it become x square is equal to 2a minus 1, and I can write x is equal to plus minus under root 2a minus 1. Okay, so plus minus under root 2a minus 1. Okay, so plus minus shows us that as there is negative, this one is negative, this one is positive, and this one is positive. There are two positive, two negative, and from this we got one positive and one negative. Other positive and negative will be get through solving this, but currently I don't prefer to solve because we are getting a by solving just the left side. Okay, we got x equal to plus minus under root 2a minus 1. Okay, if I take positive 2a minus 1, so I will take other two positive values. One is 3 and the other one is negative 5 plus under root 14. If we notice, under root 2a minus 1 matches the structure of this or matches the structure of this. This is possible if this becomes a square number. Okay, if this becomes a square number, this structure is positive. This structure is never ever possible. How? You say if there is a non-square number, this structure is possible. I will say no. If there will be non-square number, this structure will be possible, not this one. So this got cancelled. So we got that under root 2a minus 1 is equal to 3. Now we will square both sides. It will become 2a minus 1 equal to 9, and that negative 1 will move towards right. It become 10, and then a is equal to 5. If you solve this, if you solve down this, okay, you will get x in the form of a, which you will equate with this negative 5 plus under root 14 or negative 5 minus under root 14. Okay, so that's wrap up question 6. Notice how breaking it down into asymptotes and intercepts makes sketching straightforward. If you found this helpful, like breaking down each and everything and explaining basics also along with this, so don't forget to like and subscribe my channel, and if you have any query you can comment it. So thank you for watching this.